Hello again. Here we have a new simulation regarding momentum and collisions. We have two cards, card 1 and card 2, and we can adjust their masses, their velocities, the elasticity of the collision, and work on the way they behave. For example, in the first case, we can choose the cards to be of the same mass, m. You can see over here. I have checked this one. We can change it. Double m, or 3m, or m.3m, etc. Let's start with the first one. We can take here this bar and move it and adjust, the velocity of the red one. Let's say 3 meters per second. It is supposed to be to the right. The positive sign indicates a direction to the right, to the positive x-axis. And you can put the other one to be -3, which means it moves initially before the collision at the direction of the negative x-axis. And here is a point of interest. It says elasticity of the collision, which means for 0, it is what we say perfectly inelastic. They stick together and we have a combined mass. And for 1, it is perfect elastic, which means that we don't have any loss of energy at all. Let's start with this one. 0 elasticity, which means perfectly inelastic collision. We click play. You can see that after the collision, let me show it again. You can see that after the collision, the combined mass remains at rest, which means that the momenta of the two moving objects before the collision had opposite directions and equal magnitudes. But now let's change the masses and put double m and m. But let the velocities, the speeds, remain the same. The velocities, yes. And let's try it again. Now you can see that the combined mass is not at rest anymore the moment after the collision. Let's watch it again. You can see that it moves to the right, to the positive axis direction, which is an indication that the momentum of the red card was larger in terms of magnitude compared to the momentum of the blue one before the collision. And as a consequence of the principle, the main principle of conservation of momentum, the combined mass, the system is moving to the right, which is the direction of the velocity of the greater mass. So in this way, you can play, you can check which graphs you want to be displayed. Momentum, energy, velocity, let's say position. Look at this. You can see the position, how it changes. It can change according to the given velocities and masses. Let me reset it. So in this way, you can click all these options and play a little to understand how the principle of conservation of momentum is applied for a perfect inelastic collision. Of course, you can do something else. You can put the elasticity of the collision equal to 0 and watch that things are different now. You can see they bounce. But of course, it's something that you have to check by yourself. You have to spend some time to practice a little, and then you get your results. Thank you again.